Alright, well this will be video 3 of the video series for structured text. As you know, there are 5 constructs. There are an if, then, and else function. There's a case function. There's a for do function. There's a while do function. And there's a repeat until function. Now, again, we will be going through, this will be the while function, the while do function. And so we went through, just to kind of recap, we went through video 1, which was the if, then, else function. Video 2 was the case function. Then you can look back at the videos if you need to. Video 3, this is what this one is, will be the while do function. And again, we will be using the RSLogix 5000 emulator. So there is no physical hardware whatsoever. I was still online from the last video, so we'll just take this offline. And I have adjusted the simulation logic so that it coincides with the logic that I'm going to be doing. So in the main routine, I have adjusted the logic and put the I've jumped around the other logic so it's not scanned anymore. So without further ado, we'll be programming the while do function. So to start off with, what we need to understand is when we open a function or we open a statement, that we end it with that same statement. So while, so for instance, we'll be using the bit level of this, and you know we've had our tags made from the previous videos. So this is a bit, the bool. So state 1 will be a bool. Then we'll say and not state 1. Then we'll say excuse me. Then we'll say do state equals 0. And then we'll exit and we will end the statement with the end while. So with that said, while state 1 bit is on and state 1, while state 0 bit is on and not state 1 bit is on, do this function. So do state is in state 0. So if you remember, this is a dent. The state tag is a dent. The state 0 and state 1, state 2, state 3, state 4, and so forth are bools, so they are standard bits. And again, make sure you put your naming culture correct. So start the statement with a while, end it with a end while. And what we'll do to make this really simple is, again, we'll go through and copy and paste, and we'll just change our bit levels and our states. So remember, we have 6 states that we're doing. So that's 1, 2, 3, 4, 5, 6. I think it's actually 0 and then a next one. Okay, so what we want to do on this first, or state 1, is say if state 1 and not state 2, then, or I should say do state 1. So change it to state 1. Now if state 2 bool is on and not state 3 bool, then move the 0 or move state into 2, the dent into 2, and we'll change this to state 3. So if state 3 bool is on and not state 4, then transition a 4 into the state. And keep in mind, this is reading, unlike standard ladder logic, this is reading right to left. So whereof it's actually executing the same direction, but if you look at what state this would be in, it's right to left. So we'll just continue doing this, and so I actually put the wrong state in that one. So make sure you put the right states and the right bits. I mean, logically you can program this however you want to. This is just a small example of how you can do it. And this will be state 6, and state 0 changes to state 6. So just a quick recap. We wrote the first statement, and to make it quick, what we did is we copied and pasted, and then we copied and pasted. We come back and change the bit level, or whatever bit we wanted to use for the while, and then the comparison. And this is an example. So you can do this for speeds. You can do this for many different applications. So in our scenario, for the sake of this video, we did it real quick, cut and dry, just the same logic we've been using. So we want to say while state 0 bit is on and not state 1 bit is on, change the state into state 0. So all we're doing is if state 0 bit is on, it equals state 0. Similar to what we did with the if, then, and else function, and also with the compare function. So it's just a different way of writing this functionality of using the while do function of or construct of the structured text format. And so again, to go back through this, again, I would say if. So while state 1 bit is on and not state 2, so change the state dent into 1. Good. And to go through this again, we'll or to keep going through this, we'll go if while state 2 and not state 3, do state 2. While state 3 bit is on and not state 4, then it's in state 3. And then we can come back and put again the same rung or the comments to this program. Make sure you do the /, and then we'll put this is a while do example of transition of state. And it would be helpful if I spelled that right. Anyway, so the purpose of that is to show you again how to add a comment. to comment it out and not have it used as a part of the program, make sure you use your forward slashes. And this gives the ability to somebody to come behind you and look at what you're doing, right? So your interpretation of what your program or what you have just programmed and how it should work. So if, say for instance, it got changed or somebody was troubleshooting it, they know exactly, somebody can go behind you and look at what you've done by the comments. Similar to a run comment, it's the same principle. So if you do change something, just put a comment below, right? Just put it in. Just make sure you use your forward slashes and comment it out. So real quick, we'll show this running. So we'll check to make sure we have no errors. And we'll go in and we'll download to our virtual chassis. It's still labeled fault handling example. That's a fault. That's another video that we did. So you can look back at the YouTube channel to see exactly what we have. We have a lot of helpful videos, and we'll steady be producing more and more. So right now, this is our logic. It accepted fine. Everything's good. Our simulation logic is working. Right now we have the simulation to transition the move bit at 2 seconds. So you see it is going down, right? It is working. What we want to do is go to structured text. We want to make sure we put on the view and then the watch function. Again, you can use Alt+3 and we'll get the logic, just the logic up here to see, so you can see. So it's on a 2-second rotation, 2-second scroll through, so that every time the timer comes in for 2 seconds, it will transition. And it basically cuts these bits on. Now you don't see these bits coming on because they're just on for a scan rate. I'm not holding them on any longer than that for the sake of, really there is no purpose to do it. So keep in mind when you are using structured text that is a lot faster, you generally don't see stuff. So if you wanted to see like one of those state bits coming on, you could use a trend or something. You could come in and build a trend. I'm not going to use it because it requires a lot of memory for a emulation. I mean, it could be done and it can work, but it would just basically slow the video time down. So for the sake of the video, we won't do it. So we do know that our logic is working. So while this state's coming on and that state's not on, it goes to 0. Now let's just see it work a little quicker. So we'll put the timer, the simulation timer, at half a second. Come down here, and again, so just so you know, if you ever get off of it, go to View and go to Watch, and you can watch it transition. So you see our state right here, and that's that very dent right there that we're using. It's transitioning, all the way through the logic as it should. So while the bool is coming on, then while one bool is coming on and not the other, it's transitioning to the other state, whatever state you would require. So we could do this to whatever we wanted to. We could say, we could have it go to state whatever. We could indicate state 10 or 0, 10, 20, 30, 40, something like that if you wanted to. If you kind of wanted to get out of the box with it, for the sake of this video, just wanted to show, how to program it, how to do a while, a do, and that's basically a while do, and make sure you use the correct opening points and the endpoints. I'll say, for instance, we come in here and we took out the exit. So it would still work. I just, you know, actually, that's kind of funny. It didn't work. It didn't work, and let's see why. This is really helpful. So the watchdog had expired. So what happened is you got stuck. It got stuck in an infinite loop in this very first one right here. So this is very helpful. I'm kind of glad I did that. So you can go in and look at the watchdog fault and look at the fault of the processor, and it may have been caused by an infinite loop or a complex program that's running too high, and it tells you exactly the routine program and the type of the code, or the type of the fault, and the code type of the code. So we'll clear that real quick. When it's not running at the time. So that was kind of important. You know, let's see. Put the exit back in. So make sure you do the exit. It's kind of important. But that was very helpful to show real quick on what would happen. It just gets stuck in an infinite loop right here. But I do have a fault program, or a program that I use for fault handling, which is the one you kind of seen that you can use as a fault handler up here, and also a program fault, so that you would have got that very fault code and you would have actually seen what transpired. So you could come back, say that happened in the middle of the night, you would know exactly what caused that fault, and you could look back at it and say, okay, or, you know, we don't always look at our programs all the time, so we don't always have them open. So if the fault had occurred, you could come back and it would trap the fault code, and even if somebody reset it in the middle of the night or reset it to get it back running, you could detect exactly what happened just by looking back at the fault code, and you would know exactly where in the logic you might have a problem, and you could fix it. So not to get off topic, anyway, so this is how you program a while do. Note the exit is important, and the exit is important to show the infinite loop scenario. So you don't want to get caught in an infinite loop. You want to make sure you shut the loop off. Make sure you shut the while do function off. Just kind of make sure it exits out, or it's going to steady keep going like in here. Actually faster than the processor can handle. So you know, it will fault, or it can fault. Most likely it faulted out because of I'm using the emulator, but it's all the restraints of what kind of processor you're using. If you're using the L5, L6, or L7, or if you're using the new L8s. L8s have a lot more power, but a lot of us are not using that yet. So just keep in mind, using a while do, make sure you program the exit, and then the exit of the while, or the end of the while statement would be end, and then whatever statement you're using. So again, I hope this was helpful and showing how this works, showing how a while do is programmed, how to program one, what can happen, what will happen, and you know, just the things that are helpful to understand, you know, what you can do with this. Again, this breaks it down a little bit simpler than a if, then, else format. The if, then, this format is really powerful, but it's more of a deep logical scenario, whereof this is really easy, cut and dry. You can tell exactly what's going on. Some things are a lot easier for some people, some things are not. So just note that there are different types of constructs that you can use in structured text to help you out. So again, hope this was helpful. And if you did like this, we will have more videos to come. We'll be sharing a lot more information as the things grow, as things get better, technology changes, we need to have the base foundation of what's going on. And this is the best way. I mean, sharing it through YouTube, just helping out, keeping everybody, as we learn, we need to share, and that's the way we all get better. So again, if you like this, please subscribe, and if you would leave me a comment on what you would like to see, or maybe some things that you feel like we could share to help you, or maybe some things we could change to maybe show you a different avenue to what you need to do, or what we could do to make things better, make our videos better. Okay, thank you, and we'll have more videos to come. Again, this was video 3 of the 5-part series video of the 5 constructs of structured text. Okay, so thank you for your time, and I appreciate it.